1/6. Other types of equations. We just grouped them together and called them other. Okay? Now, 2 of them actually have a name. Then there's another group that's really called like the others. They don't really have a name, okay? But the first group we're going to look at are going to be the rational equations. Okay, the rational equations. And we've talked about that word rational. That means fraction, okay? So, first example, if we have -2 over x minus 3 plus 3 over x plus 3 equals -12 over x squared minus 9. Now, if it's an equation, you know you're solving for x, okay? I want to know, what does x equal? Now, this incorporates what we just did in those review sections, meaning, where is x located? On the bottom of a what? Fraction. So this goes back to that domain stuff. If I'm looking for x, then I have to be careful what x equals, because x cannot zero out. Does that make sense? Because it's on the bottom. You can't let your bottom turn to 0. If it does, then it's undefined. It doesn't exist. That's not even an actual fraction no more, okay? So when I look at my denominators, you got x minus 3, x plus 3, and then you got x squared minus 9. Now, first off, you do know that the first 2 are the factors of the last one. Do y'all notice that? So really, this last one has both of them, okay? I need that to kind of be in your mind. Because this x squared minus 9, if you break it down, technically, he's both x plus 3 and x minus 3. Does everybody understand that? Now, when I look at them, tell me what numbers can I not let x equal? Who can x not be? Positive 3 or negative 3. Very good. You can't let the first one be which one? Positive 3, right? We can't let the middle one be negative 3, and we can't let the last one be neither one. Does that make sense? So I like to write that on the side of my problem, because that keeps me focused. That lets me know that when I start solving this, when I get down to x equals 3, that's a problem. You follow me? Because it can't be 3. Or if I solve and it gets down to x equals negative 3, that's a problem. It can't be that. Does that make sense? So I like to write on the side, and I even have these blanks on tests. Something that we're going to talk about in a minute is LCD, and then I put x cannot equal, okay? Where you see that x cannot equal, I would put the 2 numbers, -3 and who? +3. That's a reminder that you can't let them 2 numbers be x, okay? Now, let's talk about LCD. Why do I need an LCD? Because I kind of keep the same method. When we did regular equations and I gave you a fraction, we cleared it out. These are still fractions. They got a lot of junk. They got more junk on them now. I'm still going to clear it out, okay? It's better to clear out fractions than work with them. So we get an LCD, a common denominator. It's the same terminology. If you had on the bottom 2, 3, and 6, we know the common denominator is 6. Now that I'm giving you binomials, meaning x and a number, you got to use everything that's on your bottom. That's how you get a common denominator with variables, with a binomial series. What I'm saying is, you got to include everybody's denominator. You can't discriminate. You can't leave nobody off, okay? So you have to use everybody that's listed. So if one of them got x plus 3, he's part of my LCD. If one of them got x minus 3, he's part of my LCD. You follow what I'm saying? You can't pick between the 2. You got to use both of them, all right? So when I look at my common denominator is going to be x plus 3 and x minus 3. Does that cover everybody's denominator? Okay? Now, this is what I need you to get, and I'm going to erase these little 3's under here because I don't want nobody to get confused. Since I got it listed in red on the side. Now, I'm going to write this one time on this problem. Okay? I'm not going to do this on all my examples. But you're going to do the same thing we did when we got a common denominator with the regular equations, and we took 6, and you saw I multiply 6 at the top of each one, each term. I'm going to do the same with this LCD. You're going to multiply it to each term, okay? Now, when you multiply each, you ain't got but 3 terms, by x plus 3, x minus 3. X plus 3, x minus 3. X plus 3 and x minus 3. Okay, this is where the concept that we just finished with the R section comes in when I showed you about reducing. When you go to multiply, the one that is the same on the bottom cancels out. Do you follow what I'm saying? So the top number, your numerator, is going to be multiplied by the other one. Okay? So for instance, this bottom is x minus 3. So the x minus 3 that I'm multiplying by cancels. So I got to multiply negative 2 by x plus 3. Does everybody see what I just did? You multiply your top by the one that is not the same as the denominator. Does that make sense? Okay, let's move on. Let's do plus. Now here, who cancels on the second term? The x plus 3, right? So we're going to multiply that whole number 3 by who? X minus 3. Good. Do y'all see that? Okay? Keep going. Now here on the last term, who cancels? Both of them, x plus 3 and x minus 3. Do y'all agree? He has both. So both of them disappear. Both of them cancel out. So negative 12, you just bring down. You technically multiplying it by 1. So you just bring it down because it canceled out. Does everybody see what I did? Does everyone see how I canceled and made, this is my new equation. It ain't got no fractions in it. Okay? I took that LCD and what it looks like, you're multiplying your numerator by the denominator that's not on the bottom. You follow me? The one that's the same cancels. You can't use it. So now we're going to keep going. We got a regular equation. We're going to distribute. That's going to give us negative 2x minus 6 plus 3x minus 9 equals negative 12. And then we're going to what, clean up this left side. Negative 2x plus 3x is x. And then negative 6 minus 9 is a negative 15 equals negative 12. And then what we're going to do to get x by itself? Add 15. So when we add 15, x equals who? Positive 3. Positive 3. Now what did we say about positive 3? X cannot equal. Good, positive 3. Okay? So technically, that can't be your answer. Okay? Because we just had that discussion. That's the reason why we talked about that in the review section on Tuesday, that domains. You got to be careful what x equals when x is on the bottom of a fraction. And we talked about it can't be. That's why I had you to write it. It can't be 3 or negative 3. So what's your answer? If that's the only answer I had when I solved it, what's your answer? There we go. No solution. I don't have an answer. Okay? Now you do know the college algebra word is what? Contradiction. I take no solution. Contradiction. But your answer, 3 is not an answer. So you wouldn't put that in my answer blank. 3 is not an answer, okay? Now, what I like for my test, okay? This is my rule now. This ain't on my labs. You can't do this. But I like for you to draw errors, okay? I want you to draw errors. I want you to draw errors to the denominator that 3 ain't going to work in. Because that lets me know that you know that we both know that's the reason why it don't work. That's the reason why it's no solution. That's the reason why it's a contradiction. So out of the 3 bottoms, the 3 denominators, which one will 3 not work? The x minus, good. So that's the first one. And the last one, the one that got both of them, right? That's where 3 is a problem. And I just like to, that's like a checking mechanism to make sure you understand that's why it's a no solution. 3 don't work there. It won't work in them denominators. Does everybody see what we're doing? No, it looks busy, it looks a lot. But we're solving a rational equation. And keep in mind, when you do, rational means it's a fraction. And x is on the bottom. Okay, and that's what we got to be mindful of. We can't let x be certain things because it might zero it out. Okay, let's go to our second example. Three over x minus 2 plus 1 over x plus 2 equals 12 over x squared minus 4. And like I said, I'll have these blanks on tests on the side where I want you to fill in. So looking at those denominators, that's my first step is I have x minus 2, x plus 2, then I have x squared minus 4. So you do notice the first 2, again, are what? Factors of who? Of the last one. Does everybody see that? The last one's difference of squares. So that's his factor. If you was to break this down, you would get x plus 2 and x minus 2. So what would my common denominator be? Who would I have to use?
X plus 2 is minus 2.
Very good. X plus 2 and x minus 2. You use both of them. Now, that also lets us know what 2 numbers can you not let x be? Very good. 2 and negative 2. Does everybody see that? Now, I'm not going to write this at the top, but if you need to, write that LCD there. The one that's the same is going to what? Cancel. You're going to multiply these tops by the other one, okay? So that means 3 has to be multiplied by which one of my LCDs? X plus 2. Very good. 1 is going to be multiplied by who? X minus 2. Awesome. And who's going to be multiplied by 12? Neither one. Because they both what? Cancel out. Because he has both of them. Does that make sense? Does everyone see how we cancel those bottoms out? Awesome. Now you got a regular equation. We're going to distribute. Spread the love. 3x plus 6 plus x minus 2 equals 12. And we're going to clean it up. 3x plus 1x is 4x. And 6 minus 2 is a positive 4 equals 12. So we're going to get x by itself by subtracting 4. That's going to give us 8. And then we divide by 4. And x equals 2. 2. Yeah, 2 is a restriction. I like that. That means it can't work. So what's your answer? Good. No solution or contradiction. Very good. And so drawing those arrows, where does 2 cancel out? Why can I allow x be 2? The x minus 2 and the last one? Does everyone see that? Okay. Still okay? All right. Example 3. 4 over x squared plus x minus 6 minus 1 over x squared minus 4 equals 2 over x squared plus 5x plus 6. Now this time, each one of your denominators are squared. Okay, now the last 2 problems, I didn't give you 1 squared, which the factors of them were the other 2. This time, all of them are squared. So what does that mean you have to do? Factor. Once you see how I'm still incorporating factoring, do you see how it still keep creeping up? Factoring is still going to be in these sections, okay? You got to factor each one of them so you can honestly see what's down there. You can't pick no LCD by looking at it squared, okay? So we're going to take the time, we're going to factor each term, each denominator. So on the first one, we're subtracting to get that understood 1. So we're using what 2 numbers from 6? 2 and 3. And if my 1 is positive, which one of those have to be positive? Who? The 3. 2 is negative. Okay, on the middle one, this one is difference of squares. So that factors into x plus and minus 2. Okay. And last, we are adding to get 5. So what 2 numbers from 6 gonna add and give you 5? 2 and 3. And since 5 is positive, they're both what? Positives. Does everyone see that? Now, when I make that statement about LCDs, you gotta make sure you get everybody, okay? Everybody's denominator gotta be represented. Can't leave nobody off. So what would be my LCD? Let's start. X minus 2, x plus 3, and x plus 2. Is that everybody? Every denominator has 2 of those parentheses. Does everybody see that? Now let me make this statement. When you start dealing with squared bottoms, where all of them are squared, kind of be mindful when you're trying to factor, because sometimes I kind of understand factoring is not a strong suit for some of you. You gotta watch those signs. If you start writing your LCD and you got about 4 different parentheses or 5 different parentheses, you factored wrong. Do you follow what I'm saying with this? It's gotta flow. So kind of seeing if you got a plus 2. You probably will have another plus 2. You follow what I'm saying? If you got a minus 2, there's probably another minus 2. If you got a plus 3, there's probably another plus 3. It's got to match. Does that make sense what I'm trying to say? So make sure your signs are right. Take the time and check it. Because when you start doing that LCD, if you got a whole big LCD, you factored it wrong. The count of the norm is 3 different parentheses. Do you follow what I'm saying? If you start getting about 4 or 5 different parentheses, your factoring is off. Does that make sense? So look at that. Now, let's go get this, what x cannot equal. What 3 numbers can x not be? Very good. -3, -2, and 2. Does everybody see that? Does everybody see where we get that from? From those 3 parentheses, take the opposite. Set it to 0. Okay? All right. So now, when we go to multiply the tops, you're multiplying each numerator by the one he does not have. So 4 would have to be multiplied by which one of them? X plus 2. Good, because he's got -2 and he's got +3. Does everybody understand that? They canceled, so he has to be the +2. -1 has to be multiplied by who? X plus 3. Good, he got the 2's. Does everybody understand what I'm doing? You have to use the one he does not have. And then 2 is going to be multiplied by which one? X minus 2. Awesome. Does everyone see that? Okay. So we're going to distribute. That's going to give us what? 4x plus 8 minus 1x minus 3 equals 2x minus 4. Clean it up. 4x minus 1x is what? 3x. 8 minus 3 is a positive 5 equals 2x minus 4. Switch sides. I'm going to subtract my 2x and I'm going to subtract my 5. So we got x equals what? -9. Is there a restriction? Is there a problem with -9? No. So that's your answer. I don't want y'all to think all these going to be no solution and contradictions, okay? You can't get answers. So -9 is your answer. You don't need arrows because that doesn't hurt neither one of those denominators. Does that make sense? Questions? No? Still okay? Okay. Example 4. (4x plus 3 over x plus 1 plus 2 over x equals 1 over x squared plus x. Okay? Now let's look at these denominators. You got x plus 1 and you got x. Now they're both linear. Now you can't do nothing to them. They're linear. But then on the last one you got x squared plus x. If you factored that, what would you have? Very good. You have the other two. X times x plus 1. When you look at that last one, that's x squared, but this ain't no, we don't do sum of squares. The only thing you could do to factor that last one is take off a GCF of what? X. Does everybody see that? X squared plus X. All you can do here is take off X. And when you take or divide off X, well, here you're going to subtract off because that's what you do with your exponents. That's going to leave you with X plus what's understood to be sitting there if you take that X away? 1. So do you see how he is the other two? And kind of let that be rule of thumb. Unless I give you all of them squared, that's where you got to factor and figure it out. But if I give you 2 linear ones and only one of them is squared, then he got to be the other two. Does that make sense? For this to work right. His factor would have to be the first and second, or however the situation might be. Okay? Now, that's going to be, right, our LCD? X and X plus 1. Do y'all agree? Wouldn't that be all things that's on the bottom? Now, be careful. What can X not equal? We talked about this when we talked about domains. 0, good. 0 and -1, okay? Normally students can see the -1. But right here, X by itself on the bottom means it can't be who? 0. Do y'all see that? So if you just got single X, that stands for 0, meaning you can't let him be 0. But obviously out of the parentheses, y'all see that's -1. Does everybody see that? Okay. Now, here we go. Let's multiply. Let's clear out our fractions. The top one, 4x plus 3, has to be multiplied by who? X, right? And I'm going to put it in the front because it's more junk on top of that one than what I'm multiplying by. Do y'all see that? So I just put X in front. I didn't confuse nobody, then I just threw it in the front. Plus 2 is going to be multiplied by which one? X plus 1, good. And 1 is going to be multiplied by who? Nothing, just 1. Because both of them cancel. Both of them are those denominators. Is that denominator mean? Does that make sense? Okay. Now when you multiply on the first one, when we distribute, what do you have? 4x who? Squared. That's the first one I've worked that's got a square. Okay? This one is a little different. This one's quadratic. Okay, let's keep going. 4x squared plus 3x plus 2x plus 2 equals 1. Now what I mean by this one is different. The first 3 examples, you just got x's, right? You didn't get no x squared. You had just x's. So we put x's on one side, whole numbers on the other, and you got x equal a number. This is quadratic, meaning, okay, this thing gonna have 2 answers. Anytime you have an x squared, that means I'm gonna have to factor. I need that to sink in. It's quadratic. Now, I'm praying it's gonna factor because I got it in this section. But you do know there are other things, if it don't factor, it's quadratic formula. Do y'all follow where I'm going with this? But in this section, they should factor because we're trying to get solid answers, okay? But when you see x squared, that means I need to put everybody on the same side so I can combine and get a trinomial to factor. Do y'all follow where I'm going with this? You can't put x's on one, whole numbers on the other. This time I need that 1 to come over and join so I can set it to 0. Okay? Because this is squared. That's the emphasis I'm trying to make. That lets you know you're dealing with a different problem when you multiply and you got x squared. Does everybody see this? So I'm going to move that 1 over, and when I move it, it becomes a what? -1. So I'm going to rewrite. I'm going to combine while I'm doing it now. I can combine these single x's right there, can I? That makes a 5x, and I'm going to go ahead and bring this together since I wrote it like that. 2 minus 1 is +1, and I set it to 0. Do y'all see my trinomial? My 3 terms? Does everyone see that? Now, I'm going to factor. Now, honestly, you can plug in a quadratic formula, and you're going to get a perfect number, and you're going to have to split it. But that wouldn't be the recommended method, okay? Because this is going to give you two real answers, not a complex answer, all right? So, rules of factoring, we're adding, and this is not a hard factoring, to get 5. Well, in the front, you got a 4. In the back, you got a 1. What's 4 plus 1? 5. Okay? So that means I'm using 4x and 1x for my 4. I'm not using 2 and 2. Okay? And in the back, I can only use 1 and 1. Because isn't that the factors of 1? 1 times 1? And if you need to check, that's why I keep stressing, if factoring is not your strong suit, go to the side and make sure that's 4x and 1x, which will make 5x if I add it up. And since 5 is positive, that means everybody's what? Positive. Does that make sense? Now, that's it factored. But what is the zero factor property? We talked about that in 1.4. Once you factor it, now since it's set equal to 0, you got to tell me the two answers. Okay? If you need to take each parenthesis and actually set it to 0 to see it, do so. But x is going to be two different things. What is x going to equal? Negative 1 over 4, okay? And negative 1. I got two answers sitting here. Negative 1/4 and negative 1. Negative 1/4 and negative 1. Who? Negative, good. Negative 1 ain't going to work. Okay? That's why I'm stressing that. Do y'all see? You got to remember what you wrote up here. You said 0 and negative 1. That means this can't be one of your answers. Okay? Now, let me ask you this, though. Is this one a contradiction? No. Why? I still have an answer. Very good. This time you were blessed with two answers. So you can't say this is no solution. It's just one of my answers didn't work. My actual only answer is negative 1/4. Does that make sense? Okay? We say contradiction or no solution when, okay, if both of them wouldn't have worked. Or the only one answer I had didn't work. Does that make sense? But if you still have an answer, then your answer is that answer, negative 1/4. But because I knew this was going to be a problem that was quadratic, which was supposed to have two answers, I still want you to draw arrows to tell me why the other one didn't work. Why he didn't work. Where does he not work at? The x plus 1 and the last one. Does everyone see that? Questions? Still okay? Okay. Let's do number 5. X over x plus 2 plus 1 over x plus 3 equals 2 over x squared plus 2x. Okay. So we got 4 terms, but only 3 of them have denominators. Okay. We got x plus 2. That's linear. We got a single x. That's linear. But that last one is x squared plus 2x. So he must be what? Factor. But what is his factor? X and x plus 2. Do you follow me? Because I told y'all if I give you one that's squared, his factor's got to be the other two to make it work. Does that make sense? So if you factored that, that would be taken off a GCF of x, and wouldn't you be left with x plus 2? Okay? So what would that LCD be? Good, x and x plus 2, which also means what two numbers can I not allow x to be? Awesome, 0 and negative 2. Do y'all see that? Okay, here we go. So when I go to multiply, x is going to be multiplied by who? X. You want to go ahead and make that what, x squared? Y'all do see that x times x is x squared? Yes, yes, yes. Okay. Plus 1 is going to be multiplied by who? X plus 2. Now 3 has to be multiplied by who? Both. Good, because he don't even have a denominator. Does everybody see that? I got to multiply 3 by the x and x plus 2. Right? Okay, good. Equals, what about 2? Just bring it down? Good, because he is x and x plus 2. That's his denominator. He has both. Does everyone see that? So, right off the gate, when you multiplied x times x, you got x what? Squared. So we're going to have to do what with this one? Factor, right? Because we're going to have how many answers? 2. Does everybody see that? I need y'all to see the distinguishing mark that, okay, this one is different from the first one she worked. Now let's clean it up. Let's distribute and do all that good stuff if you haven't already. So that's going to give me my x squared. I keep my x plus 2. And this is going to become what? 3x squared plus 6x. Can I go ahead and move that 2 on over since I know it's got to be over here with it? Put minus 2 equals 0. Does everyone see that? Okay, when we combine, you got 1x squared plus 3x squared, which is what? 4x squared. Then we have 1x plus 6x, 7x. And then what happens with 2 minus 2? It cancels out. So I don't have a 2 terms. I ain't even got a whole trinomial. I got 4x squared plus 7x equals 0. So me factoring into 2 binomials is out the door because I don't even have a trinomial. Does everybody understand this? So technically, when looking at it, the only thing I can do is what when it comes to factoring? There we go, GCF, greatest common factor. Because I can't do 2 parentheses. It's not a trinomial. Does everybody see this? It ain't but 2 terms. So when I look at 4x squared plus 7x, what do they have in common? An x. Take it off. We're going to take off an x. That's going to leave us with who? 4x plus 7 equals 0. Now, sometimes this is harder for students to see, but wherever you have an x, set it to 0. That's where your answers come from. So even though it's not in parentheses, it's sitting on the outside. You got a whole x sitting on the outside. So you technically set it to 0. As well as 4x plus 7, you set to 0. Because isn't that where you got x's? One on the outside and one on the inside that parenthesis? So automatically, one of your answers is 0 because you took off an x. However, does it work? No. Does everybody see that? So what's the only answer you possibly could have? Negative 7/4. Very good. Because me taking off that x and knowing that it can't equal 0 just self-eliminates it. It can't be my answer anyways. Does that make sense? But again, I wouldn't say this is a no solution because my answer is actually negative 7/4. Does everybody see that? Questions? Still good? All right.
If you want us to draw x equals 0 to the x.
Yes, I forgot. Thank you. Where did he say where them arrows supposed to go since they can't be 0? X and the last one. Very good. Thank you, Adrian. Questions. Still okay? Okay. We're going to do one more, and then we're going to jump into the next type of equations. Let's do one more. Number 6. Negative 3x over 2 plus 9x minus 5 over 3 equals 11x plus 8 over 6x. Now, this one is not like the other ones with a whole binomial on the bottom, but we know how to find a GCF, especially if it just got whole numbers, okay? What makes it be in this section is because I threw single x on the bottom of one. Do you see that? You got 6x on the bottom of one of them. So that x being on the bottom makes it rational, okay? But when I look at 2, 3, and then I have a 6, what would my LCD be? What's the common denominator? 6, because don't 2, 3, and 6 go into 6? But what else do I have to include? X. Very good. Because remember, you got to use everything that's on the bottom, so it's going to be 6x. Very good. Does everybody see that? Okay, now, what can x not equal? What's the only thing it cannot be? 0. Very good, 0. Because keep in mind, in order for it to be another number bigger than 0, it has to have a plus or minus sign down there. I ain't even got no binomials down there. Okay, it's a monomial. Meaning 0 times anything cancels it out. Does it make sense? 0 times 6 gonna make it 0. Okay? Now, this is what I would do on this one because it's a little different. I'm going to do it like I did the ones we did with linear equations. It's okay because I want you to make sure you understand what you're multiplying by. I'm going to write my 6x at the top of each term. Now, I would not multiply 6x by that whole top. I would kind of do it backwards than what I did on my linear equations when I had a whole number. I would divide first, okay? I want y'all to listen to what I'm saying. I would not fool with the top till I have divided those bottoms into 6x. This is what I would do because your tops, and the reason why I don't have a whole number on the top, I got a binomial on the top. You got more junk on the top. Does that make sense? So what I would do, your whole number's on the bottom. It would be easier to divide and then what's left over, multiply by your top. That would be easier. What I'm saying is, on this first one, I'm really going to divide 6x by 2. What does that give me? That's going to give me 3x, right? And I'm going to multiply it by what's on that top, which is a negative 3x. So y'all see what I'm doing? I'm going to write this down for each one. 6x divided by 3, and this one is 6x over 6x. Y'all see what I did? I took 6x and wrote it on the top of what's on there, that bottom, so I can see it clear. I'm going to bring down my plus sign. On this second one, 6x divided by 3 reduces to a what? A 2 and an x, right? I'm going to put that top in parentheses, 9x minus 5. Do y'all see what I'm doing? Because that's what you're going to multiply it by. Do y'all see what I'm doing? Equals, now 6x over 6x is just what? It cancels. It's just 1, right? Don't that whole thing cancels? So I just bring down who? 11x plus 8. Does everybody see what I did? That is easier to me to show than you trying to distribute it on top and then do a triangle and cancel it with the bottom. Does that make sense what I'm saying? Does everyone see how I got 3x, 2x, and then nothing on the last one? Okay. So, we got negative 9x squared plus 18x squared minus 10x. Now you do see you got some squared stuff, right? Right? What can I do with this 11x plus 8? Move it over. That's what I would do. Just go on, since I'm writing, just go on, move it over. Minus 11x and a minus 8. Right? You do know it changes signs when you move it over. Right? Okay. Now I can just combine all together. So here, my x squares, they become 9x squared. Negative 9 plus 18. And then negative 10x minus 11x is a negative 21x. And I just bring on over negative 8. On down, because it's already over. And there you see your trinomial. Y'all see your trinomial? Now, I always say check if it does have a GCF, but it doesn't have a GCF. Okay, so this is just straight factoring. So we are subtracting to get 21. We'll take our time. So in the front, you got 1 and 9, 3 and 3. And in the back, we got 1 and 8, 2 and 4. So what you want to use? We subtracting to get 21. If I use 3 and 3 in the front, eight and 1 in the back, good. Because on my outside or inside, they're the same number, depending on how you wrote it. 8 times 3 is 24, and 3 times 1 is 3. And if I subtract them, would that make 21? Yep. And so 21 is negative, so that means 24 has to be negative. So that's going to be my 8. And my 3 is positive, which will be that 1. Y'all see that? And like I said, factoring, you got to go on the side and check that part, okay? Then once it's factored, you take each parenthesis and set it to 0 so you can see those two answers. So we got negative 1/3 and a positive what? 8/3. Now, neither one of them are 0, right? So they both what? Check. They both work. Does that make sense? Questions? Questions? No? Okay. The next type of equations are your radical equations. Radicals. X equals the square root of 3x plus 18. X equals the square root of 3x plus 18. Now, radical equations are kind of the inverse of the square root property, okay? Remember when we did in 1-4, the square root property, you had 2 terms. X squared equals 25. And that one's easy. Let's say negative 25. And we took the square root of both sides to get rid of the little 2, the square. Well, now that we're in radicals, this is going to be the opposite. I need to solve for x. However, one of my x's is under a square root. So I got to get rid of the square root to get the x, okay? So in order to get rid of the square root, I got to square it. Do you follow what I'm saying? When I said opposite, you got to do the opposite, the inverse operation. So squaring and square roots cancel each other out. Does that make sense? So first thing, you want to always make sure your square root is on the side by itself. And in my very first example, I did. Okay, it's by itself. If it wasn't, you would need to move it. Because you cannot square both sides unless the radical is by itself. Okay? So in this case, it is. So we're going to square. That's what I mean by square. We're going to raise it to the second power. Okay? That's going to give me x squared. And by me squaring that square root, it just takes the house off. You're left with what's underneath it, which is 3x plus what? 18. Now, you see how we still creeping up with factoring. It's squared. Do you see this? In order for me to solve for x, and I got an x squared, I need everybody to be on the same what? Side, so I can do what? Factor. Set it to 0 to factor. Does that make sense? So now, I'm going to take 3x plus 18 and move it over there with that x squared. Okay? You want to keep your x squared positive. So you move everything. You make it convenient for him. Move everything over to him. Okay? So I get my x squared here. That's a minus 3x and a what? Minus 18. Keep in mind when you move it over, it's got to change signs, both of them. So there you see your little trinomial. Okay, it's an easy one. We are subtracting to get negative 3. So we do our 2 parentheses, x and x. And then I say, okay, what 2 numbers from 18 are going to subtract and give you 3? 6 and 3. Good. 3 and 6, 6 and 3. Okay. Now, you're going to have to make sure you got the right one that's supposed to be negative. Who has to be negative in order to get a negative 3? 6. Very good. So we got a negative on the 6, positive on the 3. Do y'all see that? And then just like up before, if we're looking for x, you take each parenthesis and set it to 0. If you can't see what would cancel it out. And we get negative 3 and who? Positive 6. Okay, does everyone see that? Now, this is the main requirement. Just because you got them 2 answers don't mean they work. So now you have to check it. Okay? If you don't check it and you put them 2 on my blank, I could easily count off because one of them may not work. One of them might not check. That's a biggie with radicals, okay? So you got to take the time and plug it back in and make sure it will work. Does everybody understand what I'm saying? So the check is a requirement. You got to check this stuff, okay? Now let's put it up. Check. So if I check negative 3, you go right back to the original. And where x is, you're going to plug in negative 3. Exactly into the original. Now, by me writing this, I already know that don't check. Why? Square root, and it's set equal to a what? A negative. Is that ever going to happen? No. You can't get a negative number from under square root. Y'all should know that square roots stay positive. Even if you had a negative under a square root, we get imaginaries. You're not going to get a negative number. Does that make sense what I'm telling you? So there's no way for me to get a number under that square root take the square root of it, and it's going to be negative 3. Y'all follow what I'm saying? So I know by writing that doesn't work. But if you want me to finish off the check, I will. That's a negative 9 plus 18, which is positive 9. You see that? The square root of positive 9 is what? Positive 3. It ain't no negative 3. So negative 3, you see, it don't work. Check the 6. So here, you got what? 18 plus 18, which would be 36. And what's the square root of 36? 6. So does this one check? Yes. So your only answer is 6. Do y'all see that? It's highly important that you check. Okay? Because you're going to come up with 2 answers. Sometimes both of them don't work. Okay? Y'all see what we're doing? Let's do a second example. Okay.
Yes, ma'am.
Okay. Let's do square root of 4x plus 13 equals 2x minus 1. So is my radical by itself? Yep. So we're going to go ahead and square. Good. We're going to square both sides. That's going to give us 4x plus 13 equals. Now, this is where I always have students to mess up. That's a binomial squared. Okay? Which really is the same thing, what? Right, it's twice. Which means you got to do 4. Good. Students would love to give me 4x squared plus 1. They missed the whole middle. You got to FOIL it, okay? So I would recommend go over to the side and FOIL the whole thing out, then write it back. But don't just do the first and the last. You got to actually FOIL the whole thing, okay? So 2x times 2x is 4x squared. 2x times negative 1, negative 2x. Then we got negative 1 times 2x is another negative 2x. And negative 1 times negative 1 is positive 1. Do y'all see that? So that's 4x squared minus 4x plus 1. And I'm just showing all my steps. Now, this thing is squared. You got a 4x squared. So that means I got a factor. You got 2 answers. That makes sense? So I need to bring everybody together. Now, this time I'm taking everything to the right. Because that's where my x squared is. I always go where he is because you want to keep him positive. Does that make sense? So this time I'm taking this 4x plus 13 and I'm moving him over. So I put 0 on this side. I bring down my 4x squared minus 4x. But when this one comes over, he becomes a negative 4x too. I bring down my plus 1, and when this one comes over, this 13, it also is a negative. I'm just showing you that I did change my signs. Did y'all see that? And then we're going to clean it up. 4x squared. These 2 negative 4x's make negative 8x. And then 1 minus 13 is a negative 12. Do y'all see that trinomial? Does everyone see how we got that trinomial? Now, before I factor it, I would take off a what? GCF of who? 4. Good. That helps your factoring. Take that GCF off. So that's going to give you x squared minus 2x minus 3. And so that's an easier factor. I'm going to subtract to get that negative 2. And so I got x's at the front, and the only thing I can use at the back is what? 3 and 1. And since my 2 is negative, who has to be negative? My 3, my 1 is positive. And if need be, go to the side and check that. That's a positive 1x. Negative 3x will make a negative 2x. Now, where x is where you set it equal to 0. Now, I don't want y'all to get confused. When we took off a GCF of x, 0 was one of my answers. This ain't an answer. You took off a GCF of 4. Does 4 equal 0? No. So that didn't make sense. So you take where x is and set it equal to 0. And we have positive 3 and who? Negative 1. But we got to do what with it? You got to check them. You have to plug them back in. So I have to go to the next screen to check because my handwriting is so big. If I was to check positive 3, you take it back to the original. And I'm just plugging that 3 in. And that's going to give you, underneath this radical, you got 12 plus 13. And that's what, 6 minus 1, which is a 5. And then 12 plus 13 is 25. And what's the square root of 25? 5. So that one, 3 works. Okay? 3 is an answer. Then when I check my negative 1, that's going to give me negative 2 minus 1, which is a negative 3. And this one ain't going to check. Negative 4 plus 13 is what? 9. And the square root of 9 is positive 3. Not what? Negative 3. So negative 1 doesn't work. Does that make sense? So your only answer is positive 3. And that's my check. Y'all see that? Okay. Okay, what is this one? Number 3. Let's do the square root of 6x plus 7. Then this is not under the square root, minus 9 equals x minus 7. Okay. Now, what do I need to do first? Move 9. Good. It can't be. You cannot square this stuff unless it's by itself, the square root. So your very first thing is you need to move negative 9 over and make it a positive 9. So you have your square root equal to x plus 2. Negative 7 plus 9 is 2. And now I can do what? Square both sides. Good. So on the left, that's going to leave us with 6x plus 7. And then x plus 2 squared. Keep in mind, you are doing what? 4. Okay? So that's going to give you x squared plus 2x plus 2x plus 4, which when you combine it is x squared plus 4x plus 4. Does everybody see where I got that from? That's just 4. And if you haven't noticed, all these things going to be squared because you're squaring both sides. Do y'all see that? So you're going to have to factor. This thing has got a square on it. And so I'm moving 6x plus 7 over. So I have 0 equals x squared plus 4x. And I just like writing my terms together. I bring 6x over, make it negative. Bring down my 4. And when I bring 7 over, it's also negative. Do y'all see what I did? I just like writing it together. You don't have to. So that gives me x squared. When I combine, that's going to be a negative 2x. And then that's going to be minus 3. Same easy little factor. So again, we're subtracting to get that negative 2. So our only two numbers can be, what, 3 and 1? But who's going to be negative? My 3, 1 is positive. And then you take each parenthesis and set it to 0. So we know x is 3 and x is who? Negative 1, supposedly. Both of them, supposedly. Because you got to do what with them? Check them. Good. You got to check them. So, my original. So if I check 3, okay, that's going to be equal to a negative 4. So under this radical, you got 18 plus 7, which is what? 25, ain't it? And what's the square root of 25? And what's 5 minus 9? Negative 4. So does 3 work? Yep, 3 works. Check your negative 1. So this will give negative 6 plus 7, which that's just a positive 1, right? And the square root of 1, and we know is 1. And 1 minus 9 is also what? Negative 8. So they both what? They both check. They both work. So I don't want you to think it's a pattern to this. You got to check it. Does that make sense? And I want you to think all negative numbers don't work, because it looked like that with the first two. But this negative worked. You see, both answers worked on this one. So you got to take the time to check. Okay, there is no pattern. Just depends on if it goes back in and makes it complete. Okay? Still okay? Okay. What if number 4? We did the cube root of 4x plus 3. That's under the radical. Equals the cube root of 2x minus 1. Now these are not square roots, they cube roots. But what would I do to get rid of them? I'm still solving for x. My issue is the radical. Cube both sides. There we go. So I want you to see that it don't matter how I get rid of it, it's the same. It's just that I got to use the house number that's on that house. Does that make sense? So if you got a square root, you square both sides. This is a cube root. So I'm going to raise it to the third power. Cube both sides. If it would have been a fourth root, you raise it to the what? Fourth power. Does that make sense? You got to use its power to cancel out its house. That's the concept. So you're going to take both sides and raise it to the third power. Now all that does is just leave what's under what? Under the radical. 4x plus 3 equals 2x minus 1. Now look, is anything up here squared? No, them singles. When I say single, they're linear. You got x and a number, x and a number. Do you follow me? So this is not, let me put everybody on the same side and factor. This goes back to a basic equation where you put x's together, numbers together, so you can get one answer. This ain't but one answer. Does everybody understand? I need y'all to be able to recognize linear versus quadratic. This ain't quadratic. Ain't nothing up here squared. Does that make sense? It's a difference when we did the square, both sides, and when you start squaring, you came up with that whole x squared. You follow me? That's like, ding, ding, this is two answers. I got to factor this some type of way. Does that make sense? Here, it's linear. So we're just going to do 4x minus 2x equals negative 1 minus 3. That's going to give us 2x equals negative 4. And when you divide by 2, x equals 2. Negative 2. Okay? But I'm not going to go against the rule. The rule says you still need to do what? Check them. So plug in that negative 2 back into the original. So that's going to give us negative 8 plus 3, which that's the cube root of negative 5, right? And then this is going to give you negative 4 minus 1, which is also the cube root of who? Negative 5. I ain't asked you to evaluate it. You got the same thing on both sides, so it does what? It checks. It works. Okay? I don't need to know what's the cube root of negative 5. I just need to know both sides equal. They balanced. Does that make sense? Questions? Still okay? Okay. And we're going to stop here.